Hi folks, today we're going to look at a forces question. This is a basic question with a force being applied and you get a mass, and we're going to sort this one out. So let's read through it, see what we have, and work it out. So you're pulling a 200 kilogram sled with a force of 500 newtons and you manage to have an acceleration of 1 meter per second squared. What is the coefficient of friction, and is it static friction or kinetic friction? So let's highlight the numbers here. The highlighter's not working quite right. So there's a highlighter. Highlighter. So I got 200 kilogram sled, flying a force of 500 newtons, an acceleration of 1 meter per second squared, and we're looking for the coefficient of friction. So let's do a quick jot down what we have. In this case, we have a mass of 200 kgs. So it's a little messy. We have a force. Now, it doesn't say it's applied force, but if you read the question, you're pulling with the force, so you are the person applying the force. 500 newtons. And it says we have an acceleration of 1 meter per second squared. And we are looking for mu. So, if you recall, in forces, we have to draw a free body diagram. And I know not everybody loves free body diagrams, but the further you go in physics, the more you realize that free body diagrams make this whole process easier, because we're just going to look at it and apply the rules for net force on this one and solve from there. So, the dot represents our sled. You always have force of gravity downward. When in doubt, there's always a force of gravity pulling you downward. Of course, to counterbalance that, there's a normal force. You always have a normal force. You have a surface. If you don't have a surface, you don't have a normal force. You are always resisted by friction, unless it says ignore friction, which happens occasionally. And of course, you're pulling it, and you're pulling it with an acceleration. So I'm going to make this right vector bigger. And I'm going to put little marks on here so I know these two are equal to each other. And I'm going to free body diagram. Not a whole lot to it. So, in order to solve this, if you recall, we always do F net. So F net is all the forces to the right minus all the forces to the left, or up minus down, depending which way you're looking at it. We're going to move this to the right, so it's all the forces pointing to the right, which is the applied force, minus the forces that are pointing to the left. Now, if you go to, sometimes you look at it as all the forces, then you apply all the forces added together, and then you apply the negatives to the ones that are in opposite direction. Same idea. So we're going to look at this point, we're going to make some substitutions, and we did this in class, and maybe some of you caught on, maybe so we're kind of confused. So over here I've got the three formulas. These are the three core formulas we need for this. Everything else we can make up our F net equation. So I'm going to replace F net with MA. So instead of writing them all in separate formulas, I'm just going to merge them into one. So F net became MA. FA doesn't change because it's a measured force. And the force of friction is equal to mu times the normal force. And there's the mu we're looking for. It's right here. So we still have the normal force. If you look at our diagram, these two forces are equal. So I'm going to write down first. And I'm going to put the normal force equals the force of gravity. And this is true anytime we have a horizontal force on a horizontal surface. It changes once we get further into the study of forces, but for what we're doing, this is all we need right now. So I'm going to take my MA, bring it down, my FA, still the same, and I'm going to replace the FN with FG, and because we're just going through this and making sure everybody knows what they're doing, I'm going the extra step, and then we got one more step to go. MA is equal to the applied force minus mu. And over here, Fg is equal to the mass times gravity. That's always true. So mass times gravity. We now have all of our stuff sorted out. We now have the mass, the acceleration. We know gravity is 9.8. We can put our numbers in and solve this question. So 200 times the acceleration, which is 1, equals the applied force, which is 500. I'll fix that. That's kind of an ugly 5. So 500 minus mu. Mass again is 200, and the gravity is 9.8. So this number is 200. This equals 200 equals 500 minus mu, and this number is 1960. I want to get the mu by itself, so of course I need to get rid of anything that's added or subtracted first before we get rid of the 1960. So I'm going to move the 500 to the other side. So I subtract it because it's positive on this side. Gives me negative 300, and I get negative mu times 1960. I want to get the 1960 away from the mu, so I'm going to divide that to the other side, and that should give me a number of 0.15 rounded off. So our coefficient of friction is 0.15. So I've just taken my net force equation that goes with this, and they match. The FA is on the right, the FF is on the left. Replaced them with mass times acceleration. I worked my force of friction down to mu Fn, mu mg, and mu times mass times gravity. So sorry, mu Fg. So mu times mass times gravity. Put all my numbers in. You could also rearrange before you put the numbers in, but this is pretty good to hear. So our coefficient of friction is 0.15. The other part is it static or kinetic friction? The sled is actually moving, so if you recall, kinetic is the friction you feel when you are actually moving. So the answer would be kinetic friction. So just write that down. The coefficient of friction is 0.15, and it is kinetic friction. 0.15, it is kinetic. So, as always, if you have any questions, shoot me an email or pop in and see me. I hope you enjoyed this video. I hope it was helpful, and look for some more. Thanks.